Now that we've looked at integrating when we have 1 over x and see that it gives us the natural logarithm or natural logarithm absolute value of x back after integrating, I want to look at some issues we could potentially run into when we are integrating. If I look at this one example, I have the integral of x squared plus x plus 1 all over x squared plus 1 dx. Well, I see that as written, I can't reduce. I also notice that because on the bottom I have a binomial, I can't bring it to the top because I would have that -1 exponent, and there's nothing I can do with that to get rid of that exponent. So if the next thing I try to do is use u substitution, I might say, well, how about if I let u equal, say, the bottom, x squared plus 1. Well, I notice when I do du dx, I end up with the derivative of u with respect to being 2x. Well, I have this whole expression here. So I don't have any way of plugging du in, du being 2x dx. We've looked at it in the past, so what do I do if I have extra variables, which I do, but I have more than just extra variables. I don't even have that 2x that I need, so I'm running into multiple problems. So if I go back and I think, well, maybe it's because I chose the wrong thing for u. What if I let u equal the top instead? X squared plus x plus 1. Well, when I differentiate u with respect to x, I get 2x plus 1. Meaning I still don't have what I need anywhere up here to plug du in, du being 2x plus 1 dx if I were to take that extra step. So I see that no matter what I choose for u, I keep running into problems. Well, as you may have guessed based on the topic here, we are going to try another method when substitution fails us. We are going to try to first use long division and use that to simplify. So I'm going to go on to my next slide here. And I'm going to see if I can't not use long division on this. So doing top divided by bottom, I'll have x squared plus x plus 1 all divided by x squared plus 1. And doing that, x squared goes into x squared 1 time. 1 times x squared plus 1 gives me x squared plus 1. Subtracting, I'm left with an x, which then means that x squared plus x plus 1, this here, divided by x squared plus 1, gives me 1 plus x over x squared plus 1. So it went in there 1 whole time plus a remainder of x over my x squared plus 1. So now I'm going to go ahead and try to integrate that. Well, I remember that when I do my integral, I can separate it with the plus. So I'll have the integral of 1 plus the integral of x over x squared plus 1. So when I try to integrate this, integrating this piece here, the integral of 1, I should have a dx squeezed in there, and I did not write it. Same thing here. Integrating x over x squared plus 1, I am running into some issues here still. So I'm going to go ahead, and even though I know how to integrate this piece, I'm going to try to integrate that using substitution. So this time I'm going to let my u equal x squared plus 1. Then my du will equal 2x dx. So notice that before, when I used u substitution, it wasn't working for me. I wasn't being able to find a way to successfully plug both u and du in. But now, because I have this x, and let me write my dx in here, being sloppy. Now that I have x dx, that's part of what I want. I just need that 2. Well, we know that we can squeak a 2 in by putting a 1/2 out front, thus giving me the integral of 1 plus 1/2 1 dx. Try to squeeze that in. 1/2 times the integral of x over x squared plus 1 dx. 2x, since I put the 1/2 out front. I also have the 2 in here. And now I'm able to make my substitution. And I get the integral, I'll do all my integrating at once, of 1 dx plus 1/2 times the integral of 1 over u du. And now I'm able to integrate. I know that the integral of 1 dx gives me x. Notice that I'm not putting this in terms of u because I did not do any kind of u substitution, so I still am integrating here with respect to x. So I do get an x back plus 1/2 times, I know from the previous lecture that 1 over u does integrate to be ln absolute value of u plus c, and all I have left to do is put my u back in. Absolute value of x squared plus 1 plus c, and I am done. So just remember that if when you're trying to integrate, if there is no way to rewrite the function, and using u substitution you are unable to be successful, and you have tried multiple ways multiple things to set u equal to, that if you try long division, that may be another potential way of rewriting my function so that I can integrate it.